projectile is a particle thrown from a point of projection may have different cases. We will discuss some common cases which we have to face during solving problems in various competitive examinations and in our daily lives also. So, I am taking 3, 4, 5 certain cases under which we have to apply equations of kinematics in order to solve them. How to apply equations of motions in those particular cases is the main motto of this lecture. So, first of all, let us understand the various cases and their all the involving parameters which may affect their motion, which will result for a particular result. I am taking an example which is very simple, where projectile is projected at certain angle with the horizontal from ground to ground, as we have discussed in the previous lecture. Here, just take the overview of this situation. First, we are taking a projectile. So in the first case, projectile is thrown from ground to land on ground again. Here, the particle follows a parabolic path. Particle's initial velocity u can be written as u cos theta I k plus u sin theta j cap, and it is obvious to have acceleration vector a to be minus g j cap because it is acting vertically downward. In the second case, for the projectile, we are considering a particle which has been thrown from some height above the tower. Students, in the second case, I have taken an example in which a projectile is thrown from a certain height h above the ground. If we throw the projectile from the topmost point of this tower, which is at height h, then projectile will follow a path as shown here. Here, the landing of the projectile occurs at ground. Here, in this reference frame, I have taken horizontal to be along x-axis and y-axis in the vertical direction. Here, we can analyze the basic parameters of the motion with which this motion starts. As if we talk about the initial velocity, then it comes again u vector u is u cos theta I cap plus u sin theta j cap, where theta is this angle of projection. And if we talk about the acceleration, here also acceleration can be written as minus g j cap. With these parameters known to us, we can analyze all other factors related to this projectile. Now, we are taking next example in which projectile has been thrown from a cart, a moving cart. So in third case, students, think about a projectile thrown from a moving trolley, moving cart or moving trolley. A trolley is moving in this direction along the horizontal with velocity say v0, and we throw a projectile from this trolley at an angle theta with ground or theta with horizontal with velocity u relative to the cart. In this situation, if we talk about the possible path followed by this projectile, then this path will be of this type in reaching the projectile on the ground. Here, if we talk about the frame of reference chosen to study this particular case, in my opinion, as we have chosen in previous two cases, the projectile motion is observed from the xy reference frame having x direction along the horizontal and y direction along the vertical with the reference point O situated on the ground. Now, if we analyze this motion in this situation with respect to this fixed reference frame, we can easily find that initial velocity of the projectile with respect to ground can be written as vector u, which can be written as u cos theta plus v naught I cap plus u sin theta j cap. Acceleration, as obvious, it is taken as minus g j cap. Knowing these two parameters, especially the initial velocity, we can easily solve this problem to get all the required values associated with it. In one more example, I would like to take the condition in which projectile is thrown on an inclined plane. Say there is an inclined plane of inclination alpha and we throw a ball from the base of this inclined plane with velocity u at an angle theta with the incline. The possible path of this projectile may be of like this. Now here also we have to consider a reference frame. I would like to suggest a reference frame in which we take x axis to be along the inclined plane and y perpendicular to this inclined plane. Here, depending upon the modified reference frame which we have taken at an angle alpha with the ground, we can conclude some facts. If we do a little bit exercise with the situation like this, then we can obtain initial velocity of the projectile in vector form as u cos theta I cap plus u sin theta j cap. But acceleration is quite different for this particular reference frame, which can be written as vector A equal to minus g sin alpha I cap minus g cos alpha j cap. You have to think a little bit on this acceleration because you may resolve acceleration which is vertically downward. If we resolve this acceleration g in two mutually perpendicular directions, one along the perpendicular to the inclined plane and second one is along the incline, then we got g cos alpha perpendicular to incline and g sin theta means g sin alpha along the incline, which may be written in vector form like this. So students, I think you have seen a wide variety of various projectiles which will be thrown in various manner. Now we will further analyze all the related parameters to the projectiles thrown as shown here in some examples. So in the first example we have taken a projectile thrown from ground to ground. In the second case we have taken a projectile thrown from a tower. In the third case, projectile was thrown from a moving cart or from a moving trolley at some angle with the horizontal. And in the last special case, we have projected a projectile on an inclined plane. Here, there may be some terms associated with all these as time of flight, the distance traveled along the surface on which it has been thrown. Like in the first and second and third cases, we may take it as the horizontal distance traveled by the projectile in one time of flight.